picture. You don't have to be a flat earther to listen to this or to try to understand this. So this is the earth, the so-called earth, globe, a ball. Yeah, you have a curve. Either way you look at it, this way or this way, you have a curve. And this is about the Apollo mission, any of the Apollo missions, who went to the moon. So this is the moon. Of course, a ball, curved, yeah, as the official model claims. So they are taking off from the Cape Canaveral or something, from NASA anyway. They're going up. Yeah, this is how they take off the ball. So let's say this is how they take off the ball. This is their relative position. Yeah, and they go to the moon. You see, they go, and here they land on the moon, or they either just visited the moon, if you talk about that mission who didn't land on the moon. And then with the slingshot, by using the moon gravity, they're turning back. But bear in mind, this system, which is this system, which is in fact the system of the solar, it's in fact the solar system, the entire solar system, the moon, the earth, the sun, yeah, this is the sun in the great distance, yeah, far away. This whole system is traveling by a speed of 30 kilometers per second. You can Google this, you can find this. So the whole system is traveling 30 kilometers per second. This means both the sun, the moon, the earth, they are traveling towards the sun, because the sun is dragging this system by 30 kilometers per second. This is the so-called revolution, the revolution around the sun. Yeah, and this sun is 19 million miles away or something. So this is very far. Yeah, so then if you take the Apollo mission, they went to the moon. Yeah, it took them like 3 days to reach the moon. 3 days, while the moon and the earth, they are both traveling by 30 kilometers per second. Each second 30 kilometers. So it took them like 3 days to go to the moon, and the moon and the earth is traveling 30 kilometers per second. Bear this in mind. So if I'm going to analyze this this distance in time, it will be like 3 days or 72 hours. Yeah, so this is the distance in time. Yeah, so if you want to see the actual speed of this aircraft, of this shuttle, or anyway this Saturn rocket that went to the moon, you'll have to divide by 72 hours. Yeah, you'll have to divide the distance to the moon, and you find the relative speed of their travel. So you have to take the distance to the moon, which is like it's like I don't know, a couple hundred thousands miles. Yeah, and you find the relative speed. What I'm trying to say is that if you take a look at this 30 kilometers per second idea, speed of the system, and if this rocket is going to the moon in 3 days, 72 hours, won't this rocket lag behind because it doesn't have enough time? It doesn't have enough time. to reach the moon, because both the moon and the sun, they're traveling by 30 kilometers per second. That's the question. So if you consider this speed, which is like 30 kilometers per second, the speed of the Earth and the moon and the whole solar system, this speed is like 30 kilometers per second. By using this speed, if you see this star here, this is an asterisk, with this speed, it's enough to travel a distance to the moon in 3.5 hours. So this is like combining this idea. This is like comparing the speeds, but I'm comparing it by time. So by 30 kilometers per second, you could if this rocket would be traveling by 30 kilometers per second, it would take 3.5 hours to reach the moon. But they weren't traveling by 30 kilometers per second, because it took them 3 days, which is 72 hours. So compare 72 hours with 3.5 hours. So what I'm trying to say is that the speed of this system is 20.5 times faster than the speed of the shuttle or the rocket that went to the moon. So wouldn't they lag behind? I know this is not a very good presentation, I'm sorry, but I hope you understand the idea. So it took them 72 hours to go to the moon, while by traveling by the speed which the Earth and the moon, they are traveling towards the sun, it would take 3.5 hours to reach this distance. So aren't you going to lag behind, or are you going to be like dragged along? Are you going to feel if you're going to be dragged along? You don't have to believe in the flat Earth to ask these questions. You don't have to believe in the flat Earth. So they're traveling by 30 kilometers per second. Aren't you going to lag behind if you are this shuttle going to the moon by this very, very slow speed or motion? Ask yourself. Please ask yourself. That's the idea. So please ask yourself these questions. Thanks for watching. End of this video.